there is a frontier where the influence of our Sun begins to fade. Beyond the planets, beyond the icy bodies of the Kuiper Belt, and far outside the protective bubble of the solar wind lies interstellar space, a vast region that humanity has only recently begun to explore. Traveling through this distant frontier is Voyager 1, one of the most remarkable spacecraft ever built. Launched by NASA in 1977, Voyager 1 was originally designed to study Jupiter and Saturn. Its primary mission was expected to last only a few years. Yet decades later, the spacecraft continues sending valuable scientific information from farther away than any other active human-made object. Every signal it transmits travels for more than 20 hours before reaching Earth. Those faint radio messages provide scientists with a rare opportunity to study an environment no spacecraft had ever explored before. Despite relying on technology designed in the 1970s, Voyager 1 continues operating with extraordinary reliability. Its onboard computer possesses only a tiny fraction of the processing power found in modern electronics. There are no advanced artificial intelligence systems, no modern software updates, and no high-speed communications. Instead, the spacecraft survives through careful engineering and the dedication of mission controllers who have kept it operating for nearly half a century. As Voyager moved beyond the heliosphere, the enormous bubble created by the Sun's magnetic field, it entered a region filled with charged particles, magnetic fields, and extremely thin interstellar gas. Every new measurement helped scientists better understand how our solar system interacts with the wider galaxy. Then, during routine analysis of Voyager's communications, engineers noticed something unusual. A small portion of the transmitted data appeared different from previous observations. At first, researchers suspected a common explanation. Cosmic radiation can occasionally affect spacecraft electronics. Memory errors, aging hardware, or communication interference can all produce unexpected data patterns after decades in space. Such anomalies are not uncommon for missions operating at enormous distances. However, repeated observations encouraged engineers to investigate further. Some portions of the radio transmission displayed remarkably consistent timing rather than completely random behavior. Although unusual, this alone did not indicate anything extraordinary. Natural electromagnetic processes can sometimes generate repeating structures that initially appear mysterious until their physical origin becomes clear. To better understand the anomaly, specialists compared the new transmissions with decades of archived Voyager data. They examined signal strength, frequency stability, onboard system performance, and environmental measurements collected throughout the mission. Most spacecraft anomalies eventually receive straightforward engineering explanations. Yet each unexpected observation is carefully documented because even small irregularities can reveal valuable information about either the spacecraft itself or the environment surrounding it. As the investigation continued, another curious detail emerged. One instrument that had produced limited useful data for years briefly showed readings that differed from expectations. Rather than immediately treating the measurements as a discovery, engineers considered every possible technical explanation. Temperature fluctuations, electronic drift, calibration uncertainty, and aging components all had to be evaluated before interpreting the results. This careful process reflects how scientific investigations actually work. Extraordinary conclusions are never accepted simply because data appears unusual. Every measurement must survive repeated testing, independent verification, and detailed analysis. Voyager 1 continues providing an extraordinary opportunity to study interstellar space precisely because its instruments allow researchers to observe conditions impossible to recreate on Earth. Every transmission adds another piece to humanity's understanding of the vast region beyond our solar system. Whether today's anomalies ultimately prove to be simple engineering effects or reveal previously unknown properties of interstellar space, Voyager remains one of the greatest scientific missions ever launched. Its journey reminds us that exploration is driven not by certainty but by curiosity. Every unanswered question encourages us to look farther, measure more carefully, and continue exploring the immense universe that surrounds us. As engineers continued studying Voyager 1's unusual transmissions, they followed the same method used in every scientific investigation: test the simplest explanations first. Before considering anything extraordinary, they examined the spacecraft itself. After nearly 5 decades in space, Voyager operates under incredibly harsh conditions. Its power source slowly weakens each year, electronic components age, and high-energy cosmic rays constantly bombard its systems. Any one of these factors can occasionally produce unexpected behavior. Yet some features of the recent transmissions attracted additional attention. Certain radio pulses appeared with consistent timing rather than random intervals. While regular patterns can occur naturally, researchers wanted to determine whether the signals originated from Voyager's instruments, the surrounding interstellar environment, or Earth's own communication systems. Using advanced software, scientists compared the new data with thousands of previous transmissions. Every frequency shift, signal delay, and telemetry packet was examined in detail. Rather than revealing a hidden message, the analysis showed that the signal followed mathematical relationships that could potentially result from natural electromagnetic interactions in deep space. However, because the environment beyond the heliosphere is still poorly understood, researchers continued gathering more observations before reaching firm conclusions. Around the same time, another unusual event briefly captured attention. One of Voyager's engineering instruments reported measurements that differed from earlier expectations. Since some onboard systems have been operating far beyond their intended lifetime, mission controllers immediately investigated whether the readings reflected genuine environmental conditions or simply aging hardware. Engineers carefully checked spacecraft temperatures, power levels, communication systems, and instrument calibration. Most evidence suggested that normal aging effects remained the most likely explanation. Even so, every unexpected reading helped scientists better understand how electronics perform after decades in interstellar space. Another question soon emerged. Could Voyager's trajectory itself reveal anything unusual? Tracking a spacecraft billions of kilometers from Earth is extraordinarily precise. Tiny changes in speed or direction can result from spacecraft maneuvers, thermal forces, radio pressure, or small navigation corrections made years earlier. Mission specialists continuously compare Voyager's position against detailed computer models. So far, its overall motion remains consistent with known physics. There is no confirmed evidence that Voyager is being pulled toward an unknown object or responding to an external force beyond established gravitational effects. Still, the spacecraft continues entering regions that no previous mission has explored. Every kilometer farther from the Sun exposes Voyager to new magnetic structures, energetic particles, and plasma conditions unlike anything found within our solar system. These observations help scientists improve models of how stars interact with the surrounding galaxy. Looking ahead, researchers hope future missions will build upon Voyager's historic achievements. More advanced probes equipped with modern instruments could one day travel even farther, providing detailed measurements of interstellar space that are impossible today. Voyager's greatest legacy is not mystery, it is discovery. It transformed our understanding of the giant planets, revealed entirely new moons and ring systems, crossed the boundary into interstellar space, and continues returning scientific data nearly 50 years after launch. Although stories about mysterious signals and hidden messages often capture public imagination, the real mission is no less extraordinary. A small spacecraft built in the 1970s continues communicating across more than 20 billion kilometers, carrying humanity's curiosity into a region where no human has ever traveled. Every faint transmission reminds us that exploration rarely ends with the answers we expect. Sometimes its greatest achievement is inspiring new questions. And as Voyager 1 continues its silent journey among the stars, it remains one of the most enduring symbols of human curiosity. A reminder that even at the edge of our solar system, there is still an entire universe waiting to be understood.